Hello friends, welcome back to my channel and welcome to third lecture of dynamic programming. So today we'll solve one problem of CanSum. So and through this question we'll able to see like how to generate that recursion tree for this problem, and also how to create a recursive approach for this problem. And first we'll solve by brute force algorithm, then we'll memoize it like the previous problem. So what is the question? Like, write a function CanSum which will take two argument. First will be integer, that is target sum, and another will be like array of numbers. So if from that array of numbers we are able to generate that target value, then we'll return true, otherwise we'll return false. So for example, here 7 and 2 comma 3, and you may use any number from the array as many times as needed. Like here for generating 7 we can use 2 times and 3, like 2 plus 2 plus 3, like that. And you may assume all input numbers are non-negative, means elements of array will be positive, or non-negative means 0 or positive. Return true if the target sum can be constructed using the number, otherwise return false. Okay, so this is one example. Another example will be like 7 and array will take like 5 comma 3 comma 4 comma 7. Using this array, or also we can generate like 4 plus 3 7 only we can take then also. So first, by drawing recursion tree, we'll understand how to like find that recursive solution for that problem. So let's start. So our target sum is 7, and in first example our array is 2 comma 3. So from 2 comma 3, so what we'll do, like initially our target sum is 7. So somehow if by subtracting this number from the target sum, if we are able to get 0, means we can generate that value. Like initially our target sum is 7. If you minus 2 from it, then target sum will be 5. This is our new target sum. Similarly, if you minus 3 from 7, then you will get 4. So 4 is also new target sum. So somehow now I'm breaking this bigger target sum into a smaller one. Now same way, if we subtract 2 from 5, we'll get 3. If we subtract 3 from it, we'll get 2. If we subtract 2 from this one, you will get 1. If you subtract 3 from 3, you will get 0. So here in this path we will able to get 0, and from 1, if we subtract any number from given array, that is 2 comma 3, then we'll get negative value. So we'll ignore this case, means from here we'll return false, like we can't able to generate that value from this part. From this part we are getting 0, means we'll return true, because from here we'll able to generate that value. Similarly, from here if you do minus 2, then also we'll get 0. 3 we can't minus because we'll get negative value, so we'll ignore that case. Similarly here, if you minus 2 we'll get 2, and minus 3 will get 1. From 1 we can't further not decrease any value because it will get negative. From here if we negative 0, so there is 3 scenario, in this we are getting 0. So from here, here will return true. It will bubble up to here, will return true, because from any, if we are able to generate, mean will return true. So if you bubble up here, here, so if you see this path, then in this path you will get like 2 plus 2 plus 3 will able to generate. Here also 2 plus 3 plus 2, 3 plus 2 plus 2 we are able to generate, so will return true. So basically from this recursion tree we are able to get our base case. Means if our target sum will be 0, in that case we will return true. If target sum value is negative, like in that case, if we subtract -2 we'll get negative, that case will return false. So that will be our base case for our recursion. And in our recursion, what we are actually doing, we are every step we are subtracting that elements from array to generate new target sum. So now we'll try to do these things in our code, and let's go to the code editor. So what we'll do, we'll write one method, that name will be CanSum, and it will take, so I'm starting writing method, I'm making a static as usual, because without creating object I will call this method inside main, and return type will be boolean. Method name is CanSum. It will take target sum and array of integers, that is numbers. So what is our base case? If target sum equal 0, in that case will return true. Okay, fine. If target sum is less than 0, in that case will return false. Fine. Now what will be the recursive approach? Like what we are actually doing, if you see tree, like every step I am subtracting while array numbers from target sum and try to solve new target sum. So here same way we'll iterate through that array. Okay, and every step will get that remainder target sum. How we'll get, we'll subtract num from target sum and we'll call same method with new target sum, that is reminder, and we'll pass that same numbers array, because we can use as many times we want. So now here what will be our approach? If this value will be true, if this value will be true, then no need to check like if you see here, if we'll get this value true here, then no need to check another case. From here only will return. So we'll return from here only. No need to check another case. My screen got stuck. So from here we'll return true, otherwise outside the for loop will return. If in some case like we are not able to get that value, then like if that value not we are not able to get that value, in that case we will return false. We'll see that recursion tree also in that in which we are not able to it. So from here we'll call this method and we'll see it's working or not. For first case 7 and my integer, sorry, in Java like that we can take constant value like this. So 2 comma 3, so it should return true because from 2 comma 3 we'll able to generate 7. Sorry, here something, this will be capital CanSum, okay, true. If we take this one 4, in that case we can't generate so we'll get false. So in this case whole for loop will be like after for loop will not get that sum, so lastly we'll return false, correct? Now if we'll check with some like big value, like from 300 we'll able to get 300 from 2 comma 4. Yes, 301 we'll check. So in that case it's taking time, because if you try to draw 301 recursion tree, then this is not possible. So it will check all the recursion tree. In case of true, it was coming like when we are checking 300, it was generating result, because in some case if it will return true, then only from there only it will return, like whole for loop will be not iterated. In case of false, it will iterate all the for loop, then from here it will return false. So now for bigger value we have to memoize it, otherwise it will take so much time. If you see here, time complexity will be like from for loop we are calling recursion, so time complexity will be n to the power m, because if a number of array size is n, we are calling its m times, so we'll get, it will be exponential because recursion is always exponential, and so we have to optimize that one. So for 301, why it's taking time, we will show in recursion tree. If you try to see that, like in case of 301, if you try to see that, like first we'll minus 2, then it will return 299. Similarly, if we minus 4, it will get 297, like that. Minus 2, minus 4. So tree size will be big. From when it will reach base case, that time it will return false. So false we are returning from below after for loop, so it will first check all the scenarios, so it will take huge time for that code. So we'll memoize it. So we'll same way like our conventional approach, will memoize it. So what will be the better option for memoization here? Hash map only, because there are two things will be there. We have to store like target sum and one boolean value. So we'll take hash map, and what will be the key will be integer, because we'll take target sum, and this value will be boolean. So keeping this name as memo only. So first line, what we'll do, if memo will contain that value, will return from here only. So return memo dot get targets. Sorry, what is memo dot get targets, correct? Why we are doing like same way? If you see in this scenario, there will be numbers of similar, like here also 297 we are getting, here also 297 we are getting. So there will be lot of duplicate value. So again calculating same thing, while calculating first time only we'll store that value inside our hash map, and another time if we have to check that value, we'll look up into that map and return from here first line only. No need to iterate through that all things again and again. Okay, or here also we have to store that, put that value inside our memo object, like if memo here, if target sum is 0, memo dot put target sum true, correct? Here also we'll put memo dot target sum, memo dot put key will be target sum and value will be false, because here we are returning this is negative case scenario. Okay, and here also memo dot put target sum true, dot target sum equal to, sorry, same thing I'm doing again and again. Target sum false. Return is fine, we can return false or get same result will be there. So now what I'm doing, like I'm storing that value inside one map, and whenever we require, now we'll check this value, it should return false. And sorry, now it should run fastly, like okay, one mistake is there, like we are calling this method now, so here also we have to pass that map. No, it's uh, while calling also we have to pass that map. So here we'll create one hash map. First value will be integer, key will be integer, value will be boolean. So keeping name memo only, new hash map. Okay, maybe it will give error here also. We have to import that. I imported the it's already imported, so it should run now. What huh? Here we have to pass. No, it's creating so that's from today lecture. Today we are able to like generate one method, CanSum. So this is basically knapsack type of problem. Like we have given one target, we can able to generate that target from arrays, numbers of array or not. So what we did, like we first draw the recursion tree. From that we'll able to get our base case, then we try to that tree translate that recursion tree into our code. Then first we solve using brute force, then after that we memoize it. So that's from today lecture. Next lecture we'll see one another version of same question, like CanSum. Instead of CanSum we'll do howsum. Like here we are returning boolean, where we'll return that value, like 7 how we'll able to generate, like 2 2 3, so 2 comma 2 comma 3. Like here 7 we can generate either 3 comma 4 or 7. So we'll generate or like any of the combination by which we'll able to generate, then we'll return that value instead of boolean. Thank you from today lecture. We'll see you in next lecture.